We are going to work example 1 from the handout for series circuits, where three 20.0 ohm resistors are connected in series across a 120 volt generator. The generator can be thought of as any other power source, just like a battery. So the first thing that we're going to do anytime we have a circuit problem like this is to draw the picture of the circuit using the proper symbols for circuit diagramming. So first we would draw our battery, and then if we have three 20 ohm resistors, we can show that by our zigzag lines representing the resistors. We'll label them R1, R2, and R3. So this is a simple series circuit, and just to review the concepts, with a series circuit we only have one loop. So as we go around this loop, we decrease in voltage across each resistor. Whatever we went up through the battery in potential voltage, we lose that potential voltage, or that potential difference rather, as we come down through each of the resistors. Also remember that the junction rule tells us that the current is going to be the same everywhere through the circuit because there is no junction. So whatever current flows out of the circuit will come through each part of the circuit and all the way back to the beginning. So in this problem we have three resistors that are all equal. So when we write our givens, we'll just write those all as 20.0 ohm resistors. They won't always be equal, but in this case they are. The generator gives us our total voltage of the circuit, which is 120 volts. What we're trying to find in this case, for part A, we're trying to find the total resistance of this circuit, so the effective resistance of the entire circuit. In part B, we're trying to find the current that is through the circuit, the current through the whole circuit. Since it is a series circuit, it'll be the same everywhere. And then we're trying to find the voltage drop across each of the individual resistors. What we learned in the last segment was that for a series circuit, the total resistance of the circuit is equal to the sum of each of the individual resistors. So this being a simple series, all we need to do is add our three values, and if they weren't all the same, you would of course add what the individual values would be. Here we have three resistors each at 20 ohms, so we get 60 ohms total resistance. For part B, we're trying to find the current through the circuit. Anytime we're finding the total current, we need to use the total resistance. So we know that V equals IR from Ohm's law, and if we're trying to find the total current, we need to use the total voltage and the total resistance. So the current is going to be the total resistance, the total voltage divided by the total resistance. So we do that division. Our total voltage was 120 volts, and from part A we just found our total resistance was 60 ohms. So that gives us 2.0 amps of current. That is the current going through each of the individual resistors as well, because they're in series. Because the current total is equal to the individual values of the current when you're in a series circuit, we can use that to solve part C. We know again V equals IR. If we want to find the voltage drop across resistor 1, we need to use the current across resistor 1 and the value of resistor 1. So we would take our current, which was 2.0 amps across resistor 1, times the resistance of 20.0 ohms. And that would give us 40.0 volts. In this case, we do have V2 equals I2R2, which is going to be the same here because our current was the same for V2 as was our resistance value. But consider if we had a different resistance value for R2, we would get a different V as well. Always keep your subscripts consistent. If you're trying to find V3, you need to use I3 and R3. Just for emphasis, I'm showing this calculation. Even though it's the same, you have to understand that if we had a different resistance value or a different current value, we would obviously get a different voltage value there. Now there is a nice little check that we can do. For the loop rule, we know that the total voltage for a series connection is equal to the sum of the individual voltages. So if we look here, we have 40 plus 40 plus 40, which is 120 volts. And if you look up at your givens, that was the original total voltage that was given to us, so we can do a little self-check there. And there's always going to be one way that you can do a self-check, which is a nice thing about these problems.